Okay, now my recording's going. All right, good morning. Welcome back. Does everybody feel like we've been gone for about 10 years? Because that's how I feel. So to get us kind of caught back up, hopefully you were paying attention to my emails, but just kind of to reiterate what was going on in my emails is I posted, so for exam number 3, first of all, exam number 3 has been moved to Friday. It was originally supposed to be Wednesday, the 4th. It has been moved to Friday, the 6th. Your McGraw-Hill Connect assignments are also due the 6th. They're due the day of the test. So that has all been pushed back one lecture period. To kind of keep up with everything, exam number 3 covers chapters 11, 12, 13, and 15. Chapters 11 we covered before the snowstorm. So that's like a couple of lectures before the snowstorm. I posted chapter 15. So chapter 15 kind of sits by itself. It doesn't need anything else really to go with it. So I posted chapter 15, I think it was last Wednesday. And I told you it just needed to be watched at some point before the test. So chapter 15 is already uploaded. You can already watch it. If you haven't, that is going to be required material on the test. So make sure you watch it at some point. And then I believe on Thursday or Friday, I posted the first part of chapter 12 because the first part of chapter 12 is kind of the easiest part of chapters 12 and 13. Unfortunately, chapters 12 and 13 are some of the more difficult chapters, and so I was really putting off trying to put those online. I didn't really want to. But I ended up having to put about half of chapter 12 online. So there is also a posted lecture for chapter 12 that you should be able to find online. I think I watched the video and I didn't catch anything like this, but just keep in mind that chapter 12 and that chapter 15 recording are both from last quarter. So if I say anything about a due date or something and you're like, that doesn't make any sense, what is that? It's because it's my recording from last quarter, okay, and I was talking last quarter. I think I checked it and I didn't see anything like that, but in case I missed it, if there's anything weird in those recordings. So, again, there is a posted recording for the first half of chapter 12 and a posted recording for chapter 15, and the test has been moved to Friday. So today we are going to cover the last little bit of, or it's like the second half of chapter 12, and then we're going to start chapter 13. And then on Wednesday we will finish chapter 13, which will have us caught up and ready for the test on Friday. Okay? I know that's a lot. Hopefully you were able to get started on watching the recordings last week because I did post them early as I could. Yeah, and then what's going to happen is we actually still have a couple of days to catch up on. So in the exam number 4 section, there will also be a posted lecture. So one of our lectures will just be an online lecture. I'm trying to spread out the amount of online lectures I gave you. So we're doing a couple for this section, and then we're going to do one for the next section. So one of your lectures for the next section will be online, and that's to make up for the day we lost because we pushed the test back. Okay? Hopefully that'll make sense. If it doesn't make sense, send me an email or come by my office and we talk about it. Okay? But you do have to be in class on Friday. I know all of you guys that come to class know that, and you'd be here anyway, but you do have to be in class on Friday to take your exam. If there was something like you had a sports event that you thought you were going to be able to go to without any problems because the test was originally on Wednesday, but now it's on Friday, just email me and let me know. Okay? If there's anything, yeah.
Did we finish chapter 11?
I posted a recording for it, yep. And because that was the one, so I posted that one Friday before the ice storm. Because that was the day that class technically wasn't canceled because class was supposed to start at 11 and it was only classes that started afternoon that were canceled. But I canceled my class, or I moved it virtually, I guess is a better way to say it. And I did post that recording at like noon on Friday. Yeah.
For the missed classes, are we still going to get credit for the attendance?
Yes, everybody gets credit for attendance for those days. Okay, it'd be like it. I mean, if everybody gets credit, then it's like it doesn't exist, but yes. No, I'm going to mark you all as absent on days that you couldn't get out because your ice storm. But yes, everybody will get credit for those 3, 4 attendance days, whatever they were. All right. Any other questions? I know it's a lot to catch up on, but all of those recordings are there. Again, I tried my best to save chapters. Mostly the end of chapter 13 is where it gets real dicey and a lot of people get really confused, which is why I tried really hard to save it for in class when we were back together. So hopefully this works out. I know it wasn't super fun for anybody, but it is just the way that it is, I guess. All right, hopefully you all managed to stay warm. I don't know if anybody went back home to Monroe in an attempt to escape the ice storm and it was actually worse because Monroe got it significantly worse than we did. You would have been better off staying in Ruston, but because most of us here, I don't think lost power, but hopefully all of your houses have back power. I know some people don't. All right. So we are picking up at the end of the recorded lecture that I posted. And I am aware that there are some of you that may not have watched that first recording yet. Probably most of you haven't. If you are anything like me and you went into like the more days we had off, the more of a goblin I turned into. I was like melding with my couch the longer we stayed at home, which I imagine is what happened to a lot of people. But make sure to go back and watch the first part of chapter 12. I don't think you'll be too confused today, but there may be a couple of things where you're a little confused on. But go back and watch the first part of chapter 12. We're picking up on the second part of chapter 12. So the first part of chapter 12 was talking about the human immune system, or all of chapter 12 and chapter 13 are talking about the human immune system. And it's how we as humans defend ourselves against pathogenic infection. Because the truth of it is that we are constantly surrounded by bacteria and viruses and funguses and all different kinds of things that can cause us to be sick. And I know that when we think about our lives and our immune systems and bacteria and things like that, a lot of times it's really easy to think about the times that you did get sick, right? But if you compare the times that you did get sick to the number of times that you didn't get sick, the percentage would be incredibly, 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 incredibly low. Because you are coming in contact with pathogenic bacteria all day, every day for your entire life. And most of the time, you don't get sick. Most of the time, your immune system wins. Sometimes it doesn't, and sometimes you get sick, but most of the time, your immune system wins. So we're talking about how your body fights off or blocks those pathogenic organisms. And the first part of chapter 12 talked about the first line of defense. And the first line of defense is mostly physical barriers that kind of block bacteria or viruses and other pathogens from getting into or attaching to your body. Because remember those stages of pathogenesis, the first stage is a portal of entry. And then the second stage is basically sticking. It's attachment, right? And so the first line of defense is basically blocking things from getting in, things from coming in contact with a portal of entry, or things attaching to a portal of entry. Okay, so the second line of defense is going to be dealing with those organisms that do get past that first line. They do manage to get into a portal of entry, they attach to that portal of entry, they may even invade your tissues. But your body is going to try to get rid of those as a second line of defense. So this is looking at things that have gotten into your body, into your bloodstream, into your tissues, and are trying to actively make you sick. But your body is still going to try to block them or stop them from doing so. Now, again, keep in mind that this is still the innate immune system. And if you didn't watch that, you'll have to go back and watch it. But the innate immune system are all things that are non-specific. Okay. And these are generally fast Okay, and that'll make more sense when we get to chapter 13. We'll talk about timelines. But the innate immune system are things that are going to be very quick methods of control, and they are generally non-specific. Now, again, that's going to make more sense when we get to chapter 13 and we talk about the specific immune system. But all of these pathways, all of these ways of blocking and killing bacteria are non-specific. It is not attacking a specific person or a specific bacteria. No, I said person. It's not attacking a specific pathogen. It's just blocking things in general, right? It's kind of like the idea if you were trying to block somebody from your house, like you were trying to block invaders, you were trying to block robbers from coming into your house. You'd put up a fence or maybe an alarm system, right? That's not blocking out somebody in specific. It's not like, I know that my neighbor is trying to steal my stuff and I want to block out this specific person. No, you just have a fence and an alarm system that's going to stop everybody from getting in, right? It's a non-specific kind of thing. And that's what the innate immune system is. It's also called the innate immune system because it remains the same throughout most of your life. It is innate to your human body. It does not change. It does not adapt. It does not grow with you. It is pretty much the same from birth to death. It is innate. That word innate just means like inborn. Okay, it's something that is innate to your body. Okay, so now we're going to talk about this second line of defense, and keep in mind that the second line is still part of the innate immune system. So all of these types of control are still non-specific, they're still relatively fast, and they are going to be innate to your body. They're going to remain the same through most of your life. Okay, and so we're going to be talking about 4 general types of the second line of defense. We're going to talk about all 4. Now, all 4 of these, or most of these processes, have a lot to do with white blood cells. So our blood can be broken into 2 types of cells, for the most part. We have red blood cells, which are mostly responsible for carrying oxygen, and it's what makes our blood red. And then you have the white blood cells, which are mostly a part of the immune system. Now, there are white blood cells in the adaptive immune system, which we're going to talk about next time, but there is a large part of the innate immune system, the second line of defense, that has to do with these white blood cells. Okay, so we're going to talk about a couple of these different categories. You do have to remember their names, but white blood cells in general can be broken into 2 categories. Our first category, and I believe we've talked about this before, but we're going to cover it again, are called granulocytes. Okay, and these 3 on the left, neutrophils, eosinophils, and basophils, are all granulocytes. Another word for that is they are granulocytic white blood cells. Now, they are called granulocytes because they have granules. If you look at their cytoplasm, you'll see all these little dots in there. Those are granules, and those granules hold chemicals that are important to what they do. Okay, you don't have to know what's in them. All you have to do is know that those granules exist. So the granulocytes are called granulocytes because they have granules. They're these little granules, and I can't think of another word, a little spot that's basically a storage area for chemicals. They have granules. And these 3 over here are simply called agranulocytes. And they're called agranulocytes because every time you put an A or an an in front of the word, it just means without. So they're called agranulocytes because they do not have granules. Simple enough. Okay, so we're going to be talking about a lot of different white blood cells here. We're going to be talking about them in the innate immune system and the adaptive immune system. You do have to know which ones are granulocytes and which ones are agranulocytes. So neutrophils, eosinophils, and basophils are all granulocytes. Monocytes, dendritic cells, and macrophages are agranulocytes. Those are the 6 that you have to know. And we're going to talk about what some of these are used for. We're not going to talk about all of them, but we're going to talk about what some of these are used for as we go through the next little bit. So a big part of this second line of defense, kind of the first part of the second line of defense, is phagocytosis. And I know we've talked about phagocytosis before, but we'll do a little bit of a reminder. So phagocytosis, if you don't remember, is named that. It stands for cell eating. That's what that word means in Latin. Phagocytosis means cell eating. And our 3 major phagocytic white blood cells are written right there. They're neutrophils, monocytes, and dendritic cells. Those are kind of what we call the professional, I don't know if that's the right word, but they're professional phagocytes. So their major job within our human body, neutrophils, monocytes, and dendritic cells, are to go around and perform phagocytosis. Now, we talked about this briefly. What phagocytosis is it's basically a white blood cell that consumes and destroys foreign particles. Okay, so you can see it over here. This one is a bacterium. But remember that this can be any foreign particle. So that could be a bacteria. It could also be a virus. It could also be a drug. It could be alcohol. It could be dust. It could be a dead cell. Any foreign particle. Doesn't have to be a bacteria. In this case, it just is. But this phagocyte will basically consume this foreign particle, bacteria, virus, dust, drug, whatever it is, and then it will digest it until it is dead. And then once it's digested, it will release the waste product back out into the body. Okay? So what these phagocytes do, they have to be able to do 3 different things. The first one is that they survey and recognition of microbes, particulate matter, or dead cells. So any type of anything that doesn't belong. And if you've watched that video from the beginning of chapter 12, we use this phrase a lot, this phrase of non-self. So a big part of your immune system is the recognition of what belongs and what doesn't. So self are things that belong in your body, right? Self are things that belong to you. They are yourself. Non-self is everything else. So what these phagocytes are capable of doing is they survey, which means that they float around in our bloodstream, in our lymphatic system, and they check on everything that they see. And they will go around and look at a cell and say, yep, you belong. You have the right things. You are self. Yep, you belong. You're self. You belong here. But when it comes to something that it does not recognize, it is something that is non-self. It is something that doesn't belong here. It will consume it and digest it and destroy it. Okay? So white blood cells, particularly neutrophils, monocytes, and dendritic cells, are capable of surveying our entire body all the time and picking out things that don't belong and phagocytizing them and destroying them. Okay? So that's the second step, is ingestion and elimination of those materials. Okay? So it phagocytizes them, digests them, and destroys them. And then the third one is one that we're going to get more into in the next chapter, but I did want to put it here, is that they're capable of reading antigens from foreign matter. And this kind of goes along with recognition. It means that these cells are capable of looking at a cell and reading what is on that cell and saying, yes, you belong here. And looking at another cell and saying, yes, you belong here. And looking at another cell and saying, nope, you don't belong here. It is capable of reading those cell antigens to figure out what belongs and what doesn't. And if your white blood cells are not capable of figuring out what belongs and what doesn't, you have an autoimmune disease. And that is when your own body attacks things that are supposed to belong. So things like Crohn's disease is an autoimmune disease where your white blood cells phagocytize and destroy your own gut. Okay? Cells that are supposed to belong and are supposed to be self, but there's a problem with their self versus non-self recognition. Okay, so this is a real picture of phagocytosis. You can kind of see, so this is a white blood cell. This is its that's a terrible color for this. This is its nucleus right here. Okay, and this is the outside of its cell membrane. And then these little thingies, those little blue things in here, that right there, and that, and that, and that is all bacteria. Okay, and you can kind of see it in these other ones. See that little blue thing right there, and there, and there. That is all bacteria that these white blood cells are phagocytizing and destroying. Okay, so that is part one of our non-specific second lines of defenses. So if a bacteria or a virus or any other foreign particle manages to make it past your initial innate immune system, so things like your skin and your mucociliary escalator and urination and blinking and all of your lysozymes and your GI tract and things like that, which are words that you're not going to recognize if you haven't watched the first part of chapter 12. But if something gets past all of those first lines of defenses, it then has to get past the phagocytes. It has to get past this second line of defense. So another way that our body is capable of putting up like a second line of defense is through inflammation. And remember again that these are all non-specific ways of stopping an infection from happening. And inflammation is a word that we use a lot because inflammation itself is a very generic kind of non-specific term. Inflammation is something that happens. It's a reaction to any traumatic event in the tissues. Now, any traumatic event can mean an infection, which is kind of what we're talking about here. But it could just mean a small wound. It could mean a broken bone. It could mean a deep tissue abscess, right? It can any kind of disturbance or damage to tissues. So not just infection, any kind of damage, right? You can have inflammation in your muscles and stuff if you work them too hard. If you exercise too hard, you can get inflammation. So inflammation doesn't necessarily mean that you have an infection, but it can be an important thing if you do have an infection. So what inflammation is there are these 5 symptoms that usually go along with inflammation: pain, heat, redness, swelling, and loss of function. And most of you have probably experienced this in some way or another, right? You pull the muscle or something like that, and you have pain, redness, or even something like a bug bite, right? You get a really gnarly mosquito bite. It gets red and swells. Sometimes they get hot if you're particularly sensitive to them. Depending on where it is, you may have a hard time using it, even if you've had like a little paper cut on your finger, right? Paper cuts on your finger, they hurt, they get red, they swell up, okay? And all of those symptoms of inflammation occur because of a couple of things. So what happens in inflammation? There are 3 general stages, and I have another picture that shows these stages in just a minute. But the first one is there will be an attraction of those immune components to the injury site. So wherever the injury is, whether that's deep in your lung tissue because you have a bacterial pneumonia, or on your finger because you gave yourself a paper cut, doesn't matter. Wherever that tissue damage is, those immune components, particularly white blood cells, there'll be other ones, but a big part of that are the white blood cells will come to the injury site. And the reason for that is because those white blood cells are going to come in and they are going to perform phagocytosis and other procedures to clear away any harmful substances. And we're going to look at this in another picture in a minute. But those white blood cells basically act as a cleanup crew. They're going to go around and clean up any dead tissue, any bacteria or viruses that might be floating around. And they're also going to induce tissue repair. So they're going to induce your body to heal itself. Okay. And then the third one is kind of a similar thing, but destroy microbes and block further invasion. So that's another part of phagocytosis. Right? And most of those symptoms of inflammation occur because of this first thing. So if you are trying to attract immune components, particularly white blood cells, the best way to do that is to increase blood flow. If your body is trying to get more blood cells to the area in order to clean it up in there, the fastest way to accomplish that is to make more blood go there. And that is what causes most of those symptoms. The swelling, right? You have increased blood flow. You have more fluid flowing to the area. It's going to cause swelling. Blood is warm. That's going to cause it to be hot. Blood flowing to an area hurts. That causes a lot of pain and swelling. Redness, again, you have increased blood flow. So most of those symptoms are caused by the increased blood flow to the area. Okay, so inflammation is kind of the second type of non-specific defense that we have. It's a second line of defense. Now, inflammation works, again, we're going to talk more about how inflammation works. Chemotaxis goes along with inflammation. So this is not a separate process. This is part of inflammation. And what chemotaxis is chemotaxis is a tendency of cells to migrate towards certain chemical signals. Okay, you don't have to know what chemical signals they are or what cells are attracted to what chemical signals, but you have to know that your blood cells are specifically designed to react to certain chemical signals. Specifically, cytokines are a big one. We talked about cytokines briefly. I can't remember if I talked about it in the first part of this chapter, but we talked about cytokines briefly in previous chapters. And cytokines are just chemical signals, and it's how cells talk to each other, right? Cells cannot talk to each other physically. They're not capable of talking and say what they need. In order to communicate with each other, they send out cytokines, which are like little calling cards. They tell the cells what the body needs and where. Okay, so they're little signals. And these white blood cells are specifically designed to respond to those chemical signals. And chemotaxis, this word taxis means to move. Okay, so chemotaxis is the ability of microbes or any type of cell to move towards specific chemical signals. Okay, so that's just a definition of what chemotaxis is. And you can kind of see this happening inside of, this is a blood vessel. So right here we have a picture of a human blood vessel. Okay. And so what will actually happen in our body is, so say we have some kind of tissue injury down here, whatever it is, this is our tissue. And we have some kind of something that's penetrated that tissue. So we have some kind of injury. The cells near this injury will release these chemotactic factors, or these cytokines. Oops. I don't know why I wrote down an F. Didn't make sense. So those cells that have been damaged, the ones near the damage or the injury, their way of saying that they are damaged, their call for help, their 911 call to say, come help me, is to release these cytokines, or those chemotactic factors, are the same thing. So they release these cytokines out into the tissue, and these cytokines will eventually reach the blood. And just like when you call 911 and the fire department or the police department or whoever comes to you when you need help, when you put out that call, or they should, in theory, when you put out that call for help and help arrives, right, the police cars or the fire department or whoever responds to your call and comes to wherever that call was, your white blood cells are going to do that same thing. So the white blood cells will actually squeeze their way out of the blood vessels where they belong, right? They're blood cells. They're typically inside blood vessels. But they will squeeze their way out of the blood vessels to the area where the injury has occurred. And this is a picture of them actually doing this. So this is the edge of a blood vessel. And you can see this neutrophil right here is squeezing itself out of the blood vessel to get to where this injury is. Okay, so they are performing chemotaxis. They are responding to those chemical signals and moving towards them. Another type of taxis, if you've ever heard of this, most of us have seen it, but there's something called phototaxis, which is where things move towards light. And if you've ever had a house plant that turned the flower to wherever the light is shining at a particular time, that's phototaxis. The plant is moving towards the sun. Chemotaxis is a similar idea. The cells are moving towards the chemicals. And that is how inflammation happens. That's how this first part of inflammation, the attraction of the immune components to the injury site, happens, is because of chemotaxis. The injury site will release chemicals, and the cells will migrate there towards the chemicals. All right, so these are the stages of inflammation. And again, this one is showing injury inflammation, particularly this looks like a splinter or a tack, I guess. Some kind of something has penetrated the skin. But this applies to an infection or any other kind of tissue injury. But at the site of the injury, these damaged cells, I guess these are damaged cells. These damaged cells that were harmed during this injury will release these chemical signals, these chemotactic factors, the cytokines. And these blood cells in this capillary, a capillary is just another word for a blood vessel. So after a tissue injury happens, there will be releases of chemical signals, cytokines, and those white blood cells, particularly the phagocytes, will respond, and they will squeeze out of the blood cells to get to the area where the injury has occurred. And this movement of these blood cells to the area is what causes the inflammation. So the flowing of those white blood cells, the extra blood flow, is going to cause the swelling and the redness and the heat, all those symptoms. And those phagocytes are going to hang out and do what they do. They're going to phagocytize. They're going to consume the bacteria and cell debris. They basically work as the cleanup crew. Okay, to clean up any damage, any bacteria that are hanging around, any dead cells, any broken tissues, things like that. And eventually the rest of your body will seal up that wound and initiate tissue repair, but we're just focusing on the immune part of this for now. Okay. So that is what inflammation is. Those are the stages of inflammation. Yep.
Sorry if I missed it, but is chemotaxis different from diabetes?
He asked if chemotaxis was different than diapedesis. And no, diapedesis can happen because of chemotaxis. Diapedesis is just a specific type of movement. So that can happen because of chemotaxis, but it can also happen because of not. They're not exactly the same. Right? So another type of non-specific, so this is our third type of second line of defense of non-specific immune system, is a fever. And so what a fever is kind of what we call a global body temp change. And I'm sure everybody here has experienced a fever at least once in their life. And fevers happen, we've talked about this a little bit before. Fevers happen because most pathogenic bacteria are very sensitive to temperature. Remember that most pathogenic organisms are mesophiles. They like to grow and tend to grow best in that, we call it the 35 to 36 or 98-ish degree Fahrenheit. It's 35 to 37 degrees Celsius, 98-ish degrees Fahrenheit. And if the temperature gets too high, a lot of pathogenic organisms, bacteria and viruses alike, will die very quickly at slightly higher temperatures. And so that is a defense that your body creates in order to try to block anything from taking over. So if your body senses that you have organisms growing inside of you, it will trigger a fever. Now, we're not going to talk too much about any of this, so don't worry about it. I just had this picture up here. I don't know, I liked it. But a fever is just your body creating an unfavorable environment for these organisms to grow in. Most organisms cannot grow above normal human body temperature. When it gets slightly warmer, it will cause them to die or at least slow down their growth. Okay? And it's not a very large gap, right? Normal human body temperature or average human body temperature is about 98.6 or 7 degrees Fahrenheit. Some people run slightly colder, some people run slightly warmer. It's perfectly normal if that's not your normal body temp. My normal body temp is like 97 degrees. My doctors think it's really weird, but that's just my normal temperature. Some people run slightly warmer, some people run slightly colder. But average temp is about 98 degrees. An average fever is 100 degrees Fahrenheit. So it's only 2 degrees difference. It's a very, very small change, but the slightly higher body temperature will control the bacterial growth and viral growth. Again, most human pathogens are very sensitive to temperature, so a slight increase in overall body temperature will slow down or kill microorganisms. But again, this is a very non-specific thing. This is an innate response that your body does. It's not a response to a specific organism. It's part of the innate immune system. Something to keep in mind, though, is that fevers can also be dangerous. So we're going to talk about specific organisms, particularly Streptococcus pyogenes, in the next chapter, that can cause dangerously high fevers. So in most humans, a fever of about 103, 104 is about as high as your body can tolerate. And if you've ever had 104 degree fever, you know how bad that feels. It feels really terrible. It's horrific. And that's because at about 105 or 106 degrees Fahrenheit, your body actually starts to denature your own proteins. So a really incredibly high fever can be very, very dangerous. Your proteins will start to fall apart and your own body systems will start to shut down. And there are some bacteria that actually use this against us, like Streptococcus pyogenes. They cause very, very high fevers on purpose to try to make us more sick. Okay, but fevers of less than 105 degrees are generally part of our own immune system trying to protect us. So fevers, while they don't feel good, a lot of times are actually more beneficial than harmful, if they're under control. Okay, and then the last, I think this is 4, our last little part of this chapter are something called antimicrobial products. And this is just a general thing. We're not going to talk too much in specific except for about interferons. But antimicrobial products are exactly what they sound like. They're products, just things that your body produces that are antimicrobial. They kill microbes. Okay, so they're chemicals or substances that inhibit the growth or kill microorganisms. We're going to skip interferons for now because I'm going to talk about that one in a little bit more specific. So complement is just, I don't even want to talk about those in specific. So complement and antimicrobial peptides, you just have to recognize the name. Again, these are just substances that your body produces that kill or inhibit microbes. And these can be incredibly complicated pathways. We're going to talk about complement again in the adaptive immune system because there's part of complement that can be in the adaptive immune system, and we're going to talk more about that later. But these are just substances that kill microbes or inhibit their growth. The only one that we're going to talk about in specific, and the only one that I really want you to learn, are interferons. And interferons are very specifically antiviral products. So antimicrobial talks about any type of organism, right? And antimicrobial is something that could generally kill anything. But interferons, for the most part, are antiviral. And interferons work in a couple of very specific ways, and I think they're really interesting. So we're going to talk about them in specific. Now, interferons are a type of cytokine. They are a chemical signal. They are just a chemical that sends out signals to other cells that eventually cause the death of microorganisms. And the way that they do this is they work in 3 different ways. So when a cell inside your human body is infected with a virus, a lot of times your body will sense, or that cell will sense that something is wrong. Okay, that cell will sense that it's being invaded by something. It'll realize something is wrong. It'll realize it's being taken over. And it will send out this distress signal in the form of an interferon. It's a specific type of cytokine. And it will release these interferons. And the interferons will go to the nearby cells and into the bloodstream and do 3 different things. The first thing that it does is it signals neighboring cells to put up barriers. So it says to the neighboring cells, hey, I have somebody that's invaded me, you block yourself off. And so the neighboring cells will put up their alarm systems, put up all their defenses, they won't let anything else into the cell. It tells the neighbors to put up their defenses. Okay, it's like if there's a fire in somebody's house, you spray the neighbor's house down with water to prevent the fire from spreading. Okay, so that's kind of what they're doing. They're informing their neighbors. This cytokine, this interferon, signals the neighbors that somebody nearby has an infection, so shut it down. Okay. The next thing it will do is it will signal nearby infected cells to die. So if nearby cells are also infected, it signals, this sounds really dramatic, it's not that dramatic, but it will signal nearby cells to basically sacrifice themselves for the greater good, right? You're already infected, it's too late for you, just kill yourself. That sounds really dramatic, I shouldn't have said it like that. But, right, remember these are cells, we have millions of them, but it forces nearby cells to undergo something called And the pronunciation of this word is a hotly debated topic. Technically, I think it's supposed to be apoptosis because the PT is like in pterodactyl, it's silent, it's supposed to be apoptosis. But to me, that word looks like it says apoptosis, and I like to think of the cells popping, and it's programmed cell death. So the cells basically pop themselves, and they die. Apoptosis or apoptosis. I just like apoptosis. I think it sounds better. Whatever. I don't think it's correct, but that's how I say it. Okay, so it tells the nearby cells, if you are infected, it's too late for all of us. We just got to get out of here and save the rest of the crew, right? And then the last thing it will do is it will go into the blood and it will recruit nearby white blood cells to stimulate long-lasting immunity. Now, this is part of the adaptive immune system, which we're going to talk about next chapter. But it will signal nearby white blood cells to say, hey, it's the 911 call, right? Hey, I'm having a problem. I need help to take care of it. And those are interferons. Now, keep in mind, again, that we didn't talk about a lot of specific antimicrobial peptides. There are other ones, and they each work in very specific ways. We just talked about interferons, which is one. Okay. But that's all you have to know about antimicrobial products. Okay? Now, shoot. I am going to go on to chapter 13. I think I have to unplug this. I think I have to stop I don't want to stop it. Okay.